This video will go over writing quadratic equations from a graph, and we are going to use both vertex and standard form with writing our equations. So if you haven't watched the video on converting vertex to standard form, go ahead and make sure you watch that video first. The first graph we're going to look at is right here, and you may recognize it because we've dealt with it quite a bit when graphing from vertex and standard form. This right here is an example of our parent function. I have the point 0, 0, 1, 1, 2, 4, and 3, 9. I have negative 1, negative 2, 4, negative 3, 9. This is a function that you need to have memorized. We are going to compare all of our graphs to this function today. Now, to write this in vertex form, I'm going to plug in my vertex, and it is 0, 0. If you want to convert this to standard form, since my vertex is 0, 0, this is just going to become y equals x squared. We know from our parent function that a is 1 for this graph. So if you wanted to, you could put a 1 in front. Remember, your vertex equation is a times x minus h squared plus k. Your first step today is always to plug in your vertex. Let's move on to another one. In order to write this in vertex form, you need to have your transformations memorized. We talked about the transformations in the graphing with vertex form video. If you look at this graph, this one has been moved up 3. My vertex is now 0, 3. So if I plug this into vertex form, I am plugging in 0 for h, it didn't move left or right at all, and then I'm going to put the plus 3 on the outside. The last thing I need to check for is the a value. Well, if you look at this graph, it's still following the same pattern as our parent function. I go right 1, up 1, right 2, up 4. Left 1, up 1, left 2, up 4. So this graph has not had a vertical stretch or a vertical compression. It hasn't gotten skinnier, it hasn't gotten wider, so my a is just 1. You can put a 1 in front of the parentheses, or you can just leave it without 1. Now, to convert this to standard form, if I FOIL this out with zeros, then everything is going to cancel except for the x squared. So the standard form for this graph is y equals x squared plus 3. At this point, I want you to pause the video, try to write the vertex and standard form equations for this graph, and then check with me once you're ready. This graph has been moved right 1. It didn't move up or down at all. So if you wanted to write the vertex form, we would start by plugging in our vertex of plus 1. Common mistake, be careful. Right 1 does not mean plus 1. It means minus 1. And then since I didn't move up or down at all, I'm going to put plus 0 at the end. Watch out for the inside the parentheses. It's always opposite of what you would think. Now, this one is not getting wider or skinnier than my parent function. I'm still going right 1, up 1, right 2, up 4. It's still following that pattern. So to convert this to standard form, all I have to do is FOIL out the x minus 1 times x minus 1, and then I'm adding 0 to the end. So x times x is x squared. X times negative 1 is negative 1x. Negative 1 times x is negative 1x. And negative 1 times negative 1 is positive 1. This is going to simplify to x squared minus 2x plus 1. Moving on to our next graph, this graph has moved left 2, down 3. My vertex is -2, -3. So plugging that into vertex form, I have x plus 2 squared minus 3. The pattern has not gotten skinnier or wider from my parent function. I'm still going right 1 up 1, right 2 up 4. So you can write a 1 in front, but you don't necessarily have to. To convert this to standard form, you're first going to FOIL x plus 2 times x plus 2, and then we'll subtract the 3 at the end. So x times x is x squared, x times 2 is 2x, 2 times x is 2x, and 2 times 2 is 4. Combining like terms, 2x plus 2x combines to give us 4x, and 4 minus 3 combines to give us the 1. Our next graph has a few transformations going on. We have gone right 3, up 2, and my graph has flipped. So if you remember from our transformations from graphing from vertex form, if I plug in my vertex here, right 3 is x minus 3, up 2 is plus 2, and then to flip it, I have to have a negative in front of my parentheses. The pattern has remained the same. I'm still going right 1, even though I'm going down 1, left 1, down 1, right 2, down 4, left 2, down 4. So this hasn't gotten skinnier or wider, it has just flipped. You can write this as -1 for A, or you can just write it as a negative sign. Those mean the same thing. Now to convert it to standard form, we're going to FOIL out the x minus 3 times the x minus 3 first. Then we will distribute the negative, then we will add the 2. So it'll look something like this. X times x is x squared. X times -3 is -3x. -3 times x is -3x. And -3 times -3 is positive 9. Combining like terms, we get x squared minus 6x plus 9. Then when I distribute the negative, this is the same thing as having a -1. We get negative x squared plus 6x minus 9. I basically just changed all of the signs in the parentheses. My final step is to add the 2, making my standard form equation negative x squared plus 6x minus 7. For my next graph, I haven't moved right or left at all, and I haven't flipped, but if you look very carefully, this graph has gotten skinnier. It has a vertical stretch. Instead of going right 1, up 1, I am now going right 1, up 1, 2, 3, 4. Instead of going left 1, up 1, I am going left 1, up 4. My y value has been multiplied by a 4 because instead of my parent function 1, 1, I now have 1, 4. Instead of -1, 1, I now have -1, 4. Here's how you're going to write this with vertex form. My vertex is 0, 0. I haven't moved left or right or up or down. But now, instead of having a 1 for A, we now have a 4 in front. Remember from our transformations, multiplying by a whole number will make your graph skinnier. It'll make you have a vertical stretch. To convert this to standard form, FOILing out x minus 0 times x minus 0 is going to cancel everything to x squared. So this is going to automatically become 4x squared. Let's look at another one that's kind of similar. This graph has not moved right or left at all, but it has moved up 3. So I know that my vertex is x minus 0 squared plus 3. Now if you look carefully, I'm not going right 1 up 1, left 1 up 1 like normal. I'm not going right 2 up 4, left 2 up 4 like my parent function. Instead, I'm going right 1 up about a half, right 2 up 2. Left 1 up about a half, left 2 up 2. Let's compare those points. Instead of negative 1, 1, and positive 1, 1, I now have the points negative 1, 1 half, or positive 1, 1 half. Instead of the points from my parent function 2, 4, or negative 2, 4, I now have the points 2, 2, and negative 2, 2. What's happened here is since it's wider, my y values have been cut in half. Instead of going up 4, I'm now going up 2. And remember from our transformations, anytime you have a fraction in front of your parentheses, your graph is going to get wider. So the fraction that I'm going to use is 1 half, since all my y values have been cut in half. To convert this to standard form, I would first FOIL out x minus 0 times x minus 0. But x minus 0 times x minus 0 is just going to cancel to x squared. So my standard form equation is 1 half x squared plus 3. I want you to pause the video, try this last one on your own, and then restart once you're ready to check. Alright, this graph has moved right 2, up 1, 2, 3, 4, 5. So my vertex is at 2, 5. Remember, you write that as x minus 2 in the parentheses. If you look at our pattern, our parent function usually goes right 1 up 1, left 1 up 1. But in this case, I have gone right 1 up 3, left 1 up 3. So instead of going up 1, my y value has been multiplied by a 3. That means a is 3. Anytime your graph gets skinnier or has a vertical compression, you are going to have a whole number in front of the parentheses. Let's convert this to standard form. My first step is to FOIL x minus 2 times x minus 2. So x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. From here, I'm going to combine like terms, making this x squared minus 4x plus 4. Then I distribute to get 3x squared minus 12x plus 12. And your very last step is to add the 5. So my standard form equation here is 3x squared minus 12x plus 17. One thing I wanted to point out is if it's confusing for you to just look for the pattern on the graph, there's another method that you can use. If you actually watch the video for next class, I will show you another method for solving for A. So if you don't like using the pattern, there's another method you can use on the next video.